So looking at a trigonometry question then, this is a past mock paper, and it says that a television mast is held in a vertical position. If it's held in the vertical position, they've marked it in now as 90. Sometimes they don't. You're asked to mark it in yourself. If it's vertical, it's 90. It's supported by two metal supports, A, E and C, D, and a wire cable AF as shown. A to D is 2.4, AF is 3.7, DF is 1.8, CE 2.9, and the angle BCE is 48. And we're asked to find the length of B to E. So, B to E. With any trigonometry question, I would be pulling out the shapes and writing out the simple shapes down and drawing those out, because it's complicated to be writing and drawing over what you're already given, which is already quite complicated. So we're looking for BE, which is this length here, and straight away, by even marking in that line, I can see that BE is part of this triangle BCE. And that triangle is a right angle triangle. And if I redraw that out, the question becomes so much more straightforward. So I've got the green side, the yellow side, and the pink side. That is 90. And this is 48. And we've got 2.9. And we're looking for this side. I'm going to call it X. It's a right angle triangle. We're given an angle. We're asked to find a side. So it's SOHCAHTOA. At this point in Leaving Cert Maths, you should know how to decide which one is which. It's going to be opposite and hypotenuse, so it's going to be sine. So sine of 48 is equal to opposite, which is x, all over hypotenuse, which is 2.9. I'm going to multiply up by 2.9 so that I get x is equal to 2.9 times sine of 48. That is something we can get in our calculators. So if I put that into my calculator, I get 2.9 times sine of 48. So it is x is equal to 2.16. So that's the length of B to E. So it's really not that hard. Once you pull out the shapes, it always comes down to either a right angle triangle or a non-right angle triangle. The next part of the question is find the angle ADF. I would need to draw out the triangle, or at least bring it to light. For myself, the angle ADF, so A to D is this line here. I'm going to have this up here as D to F, and I'm going to get our other line coming down here, which is F to A. I'm going to redraw that out. That was F to A. And I have across the base, then we had A to D. And then I go up to get my triangle that looks like this. Now it's not 90 degrees in the diagram, so we have to be careful, but we're asked to find this. The diagram does not have to be spot on. It has to be a model for us to work with and to solve the problem with. That is the angle we're looking for. I'm going to call it the angle A to keep things simple. I've got that the blue side, so if I tilt this in the correct direction, it's more like this. So I've got that the blue side was equal to 2.4. I've got that the dark purple side is 3.7. And I've got this side here is 1.8. So I'm going to fill that in. So we've got a presumed non-right angle triangle. It's definitely not going to be a right angle there. So I'm not going to use Pythagoras or SOHCAHTOA. I'm then looking at what is the focus of the question. I'm looking for an angle, yes, but I don't have any other angle to work with. I'm given all of these sides and I need to find out what the length of the missing angle is. In that scenario, the focus is on sides, so I'm going to do the cosine rule. So I have a squared is equal to b squared plus c squared minus 2bc cos of the angle A, and we're going to identify each of our sides. It all comes down to the angle that you're using. If that's the angle A, then the side directly across from it has to be the side A. So that's going to be 3.7 squared. B and C, genuinely, they do not matter. It's A that matters. So just get your A right, and B and C you can fill in whatever way you like. So we've got 3.7 squared is equal to B squared, which is 2.4 squared, plus 1.8 squared minus 2 times B, which is going to be 2.4, times C, which is going to be 1.8, multiplied by cos of A. Now, a huge source of errors in this style of question is students forget that all of this is multiply. And if all of this is multiply, then the BIMDAS rules apply, and I cannot do anything until I've multiplied that out. I cannot do the subtraction. So that's going to stick together right until the end. So I cannot take it away. It's 2 by 2.4 by 1.8. I can't take it away. Okay. I can start to tidy things up though. So I'm going to have 3.7 squared, and on this side it works out to be 1369 all over 100 is equal to 2.4 squared. So if I do that out, 2.4 squared is going to be 144 all over 25 plus 1.8 squared, which is going to be 81 over 25, minus, I can multiply out 2 by 2.4 by 1.8, and that gives me 216 over 25 times cos of A. And it's that times cos of A that's going to stop us from using it in the subtraction. Okay, so I have to hold it with the cos for this part of the question. After that, I'm going to add 144 and 81, and I'm going to have it divided by 25. That works out to be 9, and I have 1369 over 100 is equal to 9. And I have this, remember, again, it's multiplied, so you cannot get rid of it. I'm then going to take away 9 from both sides. 1369 over 100, take away 9 from both sides, and I get 469 over 100 is equal to minus 216 over 25. So now what I can do, it's minus 216 over 25 times cos. I'm just going to move it over here so we've got more room. Times cos of A. If I want to get cos of A on its own, then what I need to do is divide both sides by 216, by minus 216 over 25, and then I'm going to have that works out to be minus 469 all over 864, and that's all equal to cos of A. And you can put into your calculator cos inverse of your answer from the last one, which is this, and if you do that, you're going to get that it's equal to 122.88. So that's all that it comes down to every time. Is it a right angle triangle or is it a non-right angle triangle? After that, it's going to be choosing, is it sides or angles that are the focus, and using the formula correctly.